Okay, good afternoon. Thanks so much to everyone for joining today. My name is Mike Connors. I'm the Director of Customer Success at Ecobot. This is the sixth in Ecobot and Esri's series on the convergence of technology and wetland science. Today's topic is tools and data for mapping wetlands. We have a great panel of presenters today who will be introduced in just a bit. Thanks to all of you for being here to share your expertise. And to the audience, please use the Q&A button down at the bottom of the Zoom window and feel free to ask any questions at any time that you happen to think of them. We're going to save the Q&A section for the end, so it would be helpful if please mention who your question is for, just so that we can keep them all organized. And when we get to answering those at the end, look forward to keeping a conversation going. Another quick note, we're going to email with a link to where you can find this video as well as the other videos in our series. As usual, our co-hosts today are Daniel Martin, a consultant and project manager with Esri, with a background also in ecology and mitigation. And also Jeremy Schewe, Chief Scientific Officer at Ecobot, with nearly 2 decades as a professional wetland scientist. So Daniel, feel free to go ahead and kick things off.
Thank you, Mike. And I'm not sure, I'm hearing a little bit of audio feedback. So if it's just me, then that's good. And if it's everyone else, sorry folks, and hopefully we'll get that ironed out shortly. As Mike said, my name's Daniel Martin. I'm a consultant and project manager with Esri, and I'm pleased to be the co-host on this session of Convergence of Wetland Science and Technology.
Great, and as kicking off this series, this is our 6th webinar, as Mike mentioned, and it's been a very exciting part of our contribution back to the community and to continue to foster our awareness of tools and data sets that are available to aid in the continued management, monitoring, delineation, and regulation of wetlands in the United States and somewhat abroad as well. So you go ahead and change the slides here. I always like to start off with something just to remember why we're doing this, that we're not alone. This is the big part of the driver behind this webinar series, is just to remember that we are all working in our own little containers and sometimes collaboratively together in order to continue to promulgate the places of beauty on this amazing planet, and yet also limited natural resources that we sit on. And we are the guardians, the custodians, the stewards, and the translators of all things related to water and to that interface of the terrestrial and the aquatic interface.
So taking a quick look at the ground we're going to cover today, I'm going to start with a brief introduction of the panelists and presenters, discuss digitizing data and the new wetland data ecosystem, go over some tools and data resources for mapping and monitoring wetlands, then take a trip to a couple really compelling case studies, one on the Antecedent precipitation tools and one on ArcHydro, the Hydroperiod tool. Then we will discuss the next upcoming webinar, and with the remaining time, go through some questions for our panelists. And speaking of panelists, so we have joining us Bakari Powell, who is a Hydrologist 3 with St. John's River Water Management District, Sandra Fox, who is a project manager with St. John's, Alan Ingram, a project consultant with Spirit Environmental, Jacqueline Smolik, a project manager with Spirit Environmental as well, and Dan Jokic, a water resources practice manager at Esri.
So I know for some of you who have been a part of every one of our webinars in this series, this is a familiar symbol, but I still feel like it's vital to bring this back up. As scientists, we are the interface between the real world and the digital world. We are the creators of the ascenders of data that helps us to better understand the world in terms of modeling and planning. Everything that we're doing out in the field is what will shape policy, is what will shape conservation, and is what will shape the regulation of all of our natural resources that we are in constant communication with when we are out in the field. So I just want to honor that. Thank you all for doing what you do and for helping to continue to help build a better data set across the entire planet so that we can continue to foster that and build that better for our future and for our children's future.
So the new wetland data ecosystem, I love this slide, and it really speaks to the picture emerging in wetland science, which is one of interconnectedness and shared efficiencies. This new digital ecosystem is where a network of hardware, software, and science work together in the planning and conservation of natural resources. So we're going to talk briefly about some different tools and data sets that wetland scientists are using every day. A brief overview of these is going to be the Web Soil Survey, National Wetland Inventory Mapper, Topo View, accessing USGS quadrangles, ArcGIS Living Atlas, Ecobot, and then the Antecedent Precipitation tool and Hydroperiod tool.
So we're just going to start off very briefly with some of these top level. Most of you probably already used the Web Soil Survey, so this is more of a touch in for those of you who haven't. For those of you who are looking for soils data for your project, specifically your wetland delineations or doing your due diligence for potential new monitoring sites, the Web Soil Survey is a great place to start. Big green button to get you started. Once you click that button on the Web Soil Survey's homepage, you can insert in your location data or navigate to it in the screen. And once you've created or defined an area of interest, then you can pull open all of your soil data. And then you've got a really nice lookup tool on the left that tells you what types of soils are there. And I can actually click on the different types of map unit names so that we can determine hydric class, drainage class, etc. And so here's a little breakout of what some of that information looks like. You can also download the data directly so that as shapefiles so that you can import that into your GIS software. Typically what I'm doing is importing that into ArcGIS Pro. I'm able to overlay that to my projects and then very easily see where my sample points or any of my other data is being collected within. And we'll see another option for downloading soils data in a little bit later when Daniel has a little bit of a chance to talk more. But here's some output. We can clip those project files down to our specific project and then project sample points onto those. Second one, National Wetlands Inventory Mapper. We've been having some great conversations with several different organizations, both from the nonprofit side, as well as Fish and Wildlife Service and EPA on methods to help improve this data set in the near future. Pretty excited about where that's going to go. But for those of you who have not used it, the National Wetlands Inventory Mapper, of course, gives you a great project-specific information in respect to your wetlands. So once you navigate to this homepage and you put in your location, then you're able to zoom in and actually see where some expected wetland units might be according to Fish and Wildlife Service and to other servers that are using these data sets. As most of you know, these data sets out in the field aren't always completely accurate. Usually they're accurate to a certain extent. I've found that majority of the time, that there's typically more wetlands on a site than what the NWI mapper will show. And every once in a while, there's less. And again, similar to the soil mapper up in the left, I've got this nice big red arrow pointing to it. You can download the data, and then that data can be downloaded on 2 different scales. You can either download it based on your watershed or based on the state. And then once you have those files imported, then you will be able to clip those down specifically to your project area and potentially even load those up to take you out in the field. All right, so one other one that I want to take a quick look at here. I know a few people have different sources for finding historic USGS maps. Most typically, I'm using this topo view. And the reason why I like this, again, I can search by location, and I've got the geospatial reference for that. Once I've located, I can then sort through the records that are pulled up. So looking at Lake Powhatan here and just outside of Asheville. And from that, you can see that there's 26 different maps of options that you can choose from. Most of those maps will give you KMZ, JPEG, or other formats that are actually geo-referenced. So, here on the far left is an example of the download of actually pulling down the USGS topo quad, and then the versions of that map that I can pull down. So again, I can now take those GeoGIFs or PDFs and pull those into ArcGIS, into Pro or Mapper or online. But now I want to turn it over to Daniel to talk to you about another simplified version of this.
Thanks, Jeremy. Yeah, I'm super excited to briefly touch on Living Atlas of the World, mostly because when I look at this, it just reminds me of the massive amounts of time I would have been able to save in the past if I had been aware and able to use this. So for those of you who don't know, ArcGIS Living Atlas of the World is a collection of GIS data, maps, apps, and layers, which are all authoritative, curated, and up to date. So accessing data through this, you no longer have to worry about, is this layer updated? Do I need to go and re-download it? You can access it for free, the data through Living Atlas of the World, and bring it into ArcGIS Online, ArcGIS Pro, and ArcMap. The data itself is stored on the cloud, which is great. It allows quick access, and you're able to leverage the power of cloud computing. So there is a ton of data on Living Atlas of the World, and basically folks like USGS or Fish and Wildlife Service, they work with Esri to ensure that the authoritative versions of their data is listed on the Living Atlas. So I grabbed a couple of example data sets that would be relevant for wetland delineations, just to kind of give a quick sample, but this is by no means exhaustive of the data that is available. The first one I wanted to show you is the elevation data. And it's one thing that's special about that is it's accessed through a raster service. It's an imagery layer. And what that does is it allows you to quickly symbolize that elevation into many different views, as you can see on that image on the left. So what might have taken, if you were doing this locally on the machine, a geoprocessing operation of quite some time, using the raster service, you can quickly change from slope to an aspect map in a matter of a few seconds. Through the Living Atlas, you can also access the USGS 3 depth data, which is a new and growing data set of really high quality elevation that is really, really great. Another one that, as Jeremy was discussing, the NWI data, this is in Living Atlas, and bringing it into your ArcGIS project is a simple one-click operation. I have a link here for a great blog post that was written about Living Atlas of the World and water resources. We will ensure that this link is included in the notes on the posted webinar once it's all wrapped up. A couple other examples. Soils is the same thing, a simple one click. You can bring in your hydrologic group, drainage class, hydric class. You have one map, your project map, and all of these layers can quickly be added. And as I mentioned, this is just a small sample of the available data. Some other data sets that are relevant to water or environmental projects would be hydrography, live stream gauges, flood hazard. We have a large collection of green infrastructure data sets, land use, land cover, weather, water quality. These are just a few really compelling data sets that you have quick access to.
Great, thanks, Daniel. And one of the things that I need to explore around with this a little bit more, so excited to find out more as we continue together. So just for the sake of time, I'm going to do a very brief intro to Ecobot for those of you who have not been introduced to Ecobot yet. Essentially, we are replacing the pen and paper process in a hyper-specific workflow centric tool that is designed to save time, efficiency, and also really provide a lot of specific lookup tools for the wetland delineation and monitoring for mitigation banking purposes. And so we're very happy to be partnered with Esri to be able to create some pretty awesome functionality here and some interrelationship between the softwares from the field to the office, similar to in that schematic that Daniel was talking about earlier. But what I do want to just show just in relationship here is here's a kick out from Ecobot as a result, working hand in hand with ArcGIS Pro. Actually, this one was produced in ArcGIS Online by one of our biologists here at Ecobot. So we're able to collect all the sample points and all the related data to those sample points in the field, have those hyperlinked inside of the application or to the map so you can pull that information up. And then also be able to collect your wetland units or wetland boundaries out in the field as well. But we want to take a look at a couple of tools that are getting pretty exciting here today. So anybody that is interested in finding more about Ecobot, feel free to reach out to me or my team. Anyone that wants to find out more about the Living Atlas, please reach out to Daniel. So we're going to go ahead and jump into our first case study here. And our first case study is going to be presented by Alan Ingram from Spirit Environmental in Houston. And he's going to be presenting the APT tool. So Alan, I'm going to pass it over to you.
Thank you, Jeremy. Can everyone hear me all right? All right, thanks. Well, as Jeremy said, my name is Alan Ingram. I'm with Spirit Environmental down here in Houston, Texas. I've been with Spirit since 2017. I graduated from Stephen F. Austin with a degree in environmental science. Prior to working for Spirit, I was in compliance for oil and gas in North Texas. And I've been doing wetland delineations for about 2 years now, so I'm relatively new to it. Relatively speaking, anyhow. At Spirit, we're kind of a full suite environmental firm. We do compliance work and natural and cultural resources. We do delineations, permitting, all types of things. We have a lot of different industries we work for, oil and gas, refining, transportation, things like that. And we've been utilizing Ecobot in correlation with theodolite to collect our data in the field. It's been saving us a lot of time. And then we also use Trimble handheld units to pick up our data points, which now I guess is probably going to change. So anyhow, let's kick off into the antecedent precipitation tool. That's kind of what we're here to talk about. So the antecedent precipitation tool, it's brand new this year. It's still in its beta testing form. You can't even get it right now off of the Corps' website, and you kind of use it to simplify your rainfall analysis under the new NWPR, the Navigable Waters Protection Rule. For this particular site, we had 29 acres on Cypress Creek, which is a little creek just north of Houston. We're trying to do our wetland delineations, identify our wetlands, our water bodies in this area, try to figure out how we're going to end up mitigating for this project. And so for this was our first shot at using the antecedent precipitation tool, trying to determine whether or not our site visit fell into these typical or normal conditions that you would want to see when you're performing these delineations. You kind of want to fall into a certain range between 30 and 70% of normal rainfall when you're doing a site visit. You don't want it to be too wet or too dry, because then what you're seeing on the ground may not be true for a typical year, which is kind of an important concept under this Navigable Waters Protection Rule. They don't want you to be doing your delineations during periods of flooding or periods of big drought. They kind of want what you're seeing on the ground to be typical for the area that you're doing your delineation. So essentially what the APT tool does is, you input your lat-long coordinates, and then you receive an output kind of giving you a graphic of your typical year, your expected range. So we can go to the next slide, please. Cool. So when you download and open up the APT tool, you kind of get that one little bar there, and all you do is you enter your lat longs and you run the program. So you download it to your desktop, and it's got this web interface kind of where it's pulling in this average 30-year rainfall data for the area that you're in based off the coordinates that you give it. Now that could fall within about a 30-mile radius of your site, but it's pulling a lot of this historical data. You don't have to enter just one coordinate. You can enter, you do have to enter one coordinate. You don't have to enter one date. You can enter multiple date ranges, and it will give you this feedback for those multiple date ranges. If you would just go to the next page, please. So what you receive back from your input is this little graphic on the left. It kind of shows you your normal range of rainfall averaged over a 30-year period for the 3 months prior to your site visit. And then it shows you what the site was on the day you were there. It tells you if it's wetter or drier than a typical year. And then it also gives you this Excel spreadsheet, just shows you your lat longs, and then what values it has, if it's in a normal range for rainfall, or if it's above or below average. If you could just skip to the next one, please. And here's a little closer up view of the graphic that it gives you. And you can see at the very end there, this blue line kind of tracks rainfall. And on the day of our original site visit, it was very much wetter than usual. And so we had to kind of reassess for this site visit whether or not we needed to go back and do another assessment during a time with more typical rainfall. If you would just skip to the next one, please. So as I was saying before, our outcome for this particular project area, based on the data that we got back, that it was a little too wet to really be performing our delineation on that date. We had to go back and do it on another date when we fell into our typical rainfall conditions for a typical year. And it kind of helps us to understand our hydrologic flows and our surface connections if we do our studies during a typical rainfall time, as opposed to, in Houston especially, it floods a lot. So a lot of times we'll end up with these sites that are just super wet with a lot of standing water, and it's very difficult to understand what it would be like at a typical time of the year. This kind of helps us to determine when we should be out on site. And it gives us just this more robust data to give to the Corps of Engineers to review. And this is probably the direct lean when they're reviewing delineation reports in the future. It's a little more efficient than using WETS tables. It's a little easier to digest with the graphic that you get, and it's beneficial to our clients. It saves us time, and it saves them time, saves the Corps time in reviewing as well. But like I said, this whole APT tool is still in its beta testing form. There's still a few kinks to work out, but overall, it's pretty efficient and easy to use. And you can grab it off of GitHub. That's the only place you can get it right now, to my knowledge. And there's a link provided at the bottom of the slide. Thanks.
Thanks, Alan. That was really interesting. Next, it's my pleasure to introduce Bakari, who's going to be discussing the use of Hydroperiod tool, which is part of Esri.
Yes. Can you guys hear me?
Yes, we can.
Hey, thanks, Alan. So I'm going to talk about using the Hydroperiod tool in Esri's ArcHydro toolbox. I'm a hydrologist 3 at the district. Next slide. I want to give a shout out to Sandra Fox, my supervisor, and Andrew Sutherland and Stephen Genuine, who are part of the MFO program. Next slide. So I work for the St. Johns River Water Management District, one of 5 water management districts in Florida. So I'll give a quick recap of our district's mission and talk about our 4 core missions. So we work to address water quality issues. We search for different techniques to provide flood protection. We protect natural systems. We also work with other districts, governments, and stakeholders to address water supply on a regional basis. And today we're going to be focusing on natural systems and water supply, and how the district, we set minimum flows and levels for lakes to ensure that water use does not cause great harm to the important Florida natural resources. Next slide. So the initial management problem and the driver behind the Hydroperiod tool is this question. So will changes in hydrology have a negative impact on wetlands? Next. So at the district, we have applied the Hydroperiod tool to a variety of different wetland-based projects. One in particular, the 2012 Water Supply Impact Study. So for that study, a version of the Hydroperiod tool was used to identify and quantify different wetland areas that are vulnerable to reduced inundation from different water withdrawal scenarios. So the project was vetted and overseen by the National Research Council. Next. So the tool found a home with the minimum flows and levels program at the district. And we help evaluate the effects of water level change on fish and wildlife habitat and recreation purposes as well to help determine MFLs. Next. So what is an MFL? So in Florida, the law requires the state water management districts or the Department of Environmental Protection to establish minimum flows and levels, or MFLs, for different aquifers, surface water courses, and other surface water bodies to basically identify the limit at which further withdrawals would be significantly harmful to the water resources or the environment. And at the district, we use a minimum flows and levels priority list and schedule. And we look at this list and schedule, which is updated annually. And it's based upon the importance of different listed waters to the state or region and the existence of potential adverse impacts associated with the water use. Next. So this slide is just to reiterate that there are a variety of different environmental values that help determine MFLs. You can click. So these first two specifically is what the Hydroperiod tool is used for, again, in evaluating the effects of different water levels on fish and wildlife habitats and the passage of fish, and for recreation in and on the water. Next. So this is the hydroecology used by the Hydroperiod tool and what we focus on. So 5 fish and wildlife habitats representing different components of Lake Butler, which I'll talk about later, were evaluated. So as you can see from this image, each habitat is defined by the area of the lake that has a specific depth range. And habitat areas were estimated based on a stage area curve developed using the Hydroperiod tool. So the cool thing is with the Hydroperiod tool, the effect of bathymetry and water level reduction on habitat area is actually quantifiable. Next. And the tool is also used to evaluate canoeable areas to assess the effects of water level change, talking about the recreation purposes, that key environmental value. Next. So the objectives of using the Hydroperiod tool for MFLs, the overall objective is balancing multiple demands on water resources. So water management districts, they're directed to consider those environmental values when setting MFLs. So typically the district evaluates fish and wildlife habitat through event-based metrics. But for some lakes, the event-based metrics typically used, they're not appropriate for different dynamic systems like Lake Butler. So this brought a need for the Hydroperiod tool to be used to help establish MFLs. Next. So where's the tool located? The tool is located in in Esri's ArcHydro Tools Python section under hydraulic and hydrologic modeling. And you can see the Hydroperiod name right there. Next. So this is a conceptual diagram of the Hydroperiod tool from start to finish, from the inputs to the outputs. So the tool was developed with South Florida Water Management District to work with Esri's ArcMap, and it functions primarily with a raster grid-based representation of a specific environment. So it is an iterative process where elevation values from a topographic digital elevation model are subtracted from an interpolated water surface elevation on a grid, cell by grid cell basis. And it produces a new raster surface containing elevation or depth of water for each grid cell, producing habitat statistics. Next. So there are 6 functions of the Hydroperiod tool. The tools, they leverage ArcHydro's database design for things like feature identification, default layer naming, and time series management. And I will show you a user interface of the first step. Next. So this is the user interface and for the first step, and this tool creates water surface elevation and ponded depth rasters. So with running this tool, we have not been using the interpolation option, but there's just one monitoring point that we've been using for the lakes, and the tool creates a flat pool to represent the water surface elevation. Next. This right here is the Hydroperiod tool database design from Esri, and it goes through the process and the design of the tool. So the district, we had requested Esri to provide consulting services for implementation of the tool and the ArcHydro framework. So different ArcHydro principles and inputs are used, such as stage tables, remap tables, monitoring points, and topographic DEMs. And I want to give a shout out to the architect of the tool, Dan Jokic of Esri. Next. So these are the output which are primarily used to help determine MFLs. So ponded depth rasters and water surface elevations are created first. Then classified depth rasters are created, representing standing water area. And then a volume table is created, illustrating the volume of water at different stages. So after that's created, we then create stage versus area spreadsheets and graphics of the results to provide to the MFL team. Next. So I'm going to talk a little bit about Lake Butler for this case study. So for Lake Butler specifically, habitat areas were estimated based on stage area curves developed using the tool. And I'm going to talk a little bit about how the tool was used to help develop an MFL for the lake. Next. Lake Butler is in Volusia County, Florida. It's a typical sandhill lake. It has sinkhole features, and it's part of the Teresa chain of lake system. And it's also located in the district's water resources caution area. So Lake Butler was on the MFL's priority water body list and schedule, which I talked about before. So minimum levels were needed to be established for the lake system. And to ensure the protection of these environmental functions from significant harm, metrics were developed for Lake Butler. And there are a variety of different wetland communities in the vicinity. Next. This right here is a DEM of Lake Butler, just showing some different cross sections of the lake in different directions. You can see that there are lobes from the cross sections, and the DEM elevation values range from 7 to 60 meters. Next. So this is a table, which is an example of the Hydroperiod tool output, showing different stage and habitat area for the emergent marsh habitat at Lake Butler. So emergent marsh generally extends from the edge of the shore to approximately 6 feet deep. So a maximum depth of 6 feet was used as a tool input based on the known depth ranges for the species in this community. Next. And these show the habitat area for all of the 5 fish and wildlife metrics analyzed. And as you can see, they all increase with stage, with emergent marsh having the greatest relationship, the highest slope. And the canoeable area for Lake Butler was measured as well, which is the area of the lake deep enough to canoe or kayak. So 20 inches or greater metric was used, and that also increased with lake stage. Next. This table right here shows the percentage area reduction under MFL conditions from the Hydroperiod tool. And I'm just going to talk a little bit about the habitat for sandhill cranes at Lake Butler. So the shallow marshes at Lake Butler, they provide nesting habitat for sandhill cranes and other birds. And the sandhill cranes, they have been observed in the shallow marsh habitats throughout Lake Butler, along with different nests in the large emergent marshes. So the average water depths for sandhill crane nesting, they range from approximately 0.5 to 1 feet. And so this was the depth range that was used for the Hydroperiod tool evaluation of this habitat metric. Next. And this table just retells the difference of the average acreage for fish and wildlife habitat and the canoeable area under no pumping condition. So if there was no impact due to groundwater pumping, and then under MFL's condition. So the MFL's condition equals a 15% reduction in the no pumping condition habitat area. And those areas were based off the Hydroperiod tool. Next. You can click one more time. So here's a quick animation to show the increasing stage, and specifically how emergent marsh increases from 11 feet to 24 feet of stage over time from the Hydroperiod tool. So this is really cool because you can track habitat areas at different stage values, and you can know what areas increase more or less over time. Next. And this just shows the beginning images. So the beginning emergent marsh areas at 11 feet. The total habitat area was 6 acres. And then the emergent marsh areas at 24 feet, and the total habitat area was 217 acres. So you can see that the areas with no standing water you can see them based off low depth, and you can also compare them with areas at greater depth. Next. And that's it. So I want to say again, thank you to Sandra, Andrew, Stephen, the geospatial team, the MFL team for all the help and guidance. And you can also contact Sandra or Andrew in the future as well for any MFL needs or assistance.
Great, thank you, Bakari. Great presentation. Just want to make a quick announcement. Our next webinar in honor of the election. Go out and vote next week if you haven't already. We're going to be talking about how cutting edge technology may be making a great impact on wetlands and policy changes, as well as monitoring and management. So look for that in November.
So thank you to all of our presenters for taking the time to walk us through those tools. Really great content. At this point, I think we are going to go ahead and transition into the Q&A session. We'll open it up to questions and discussion from our panelists. I'd like to remind everyone to use the Q&A tool as part of Zoom rather than the chat. To kick us off on this, I'd like to direct a question to Dan. Dan, as the ArcHydro development lead, could you speak to the regular updates and maintenance that users should keep in mind?
Yes, excuse me. Yeah, so ArcHydro is an interesting construct at Esri. It's really not a product. It's a free add-in. It has its own life cycle, which is not tied into our official releases of Esri's core software. We keep in step with it. So when there are releases of both ArcMap platform and Pro platform, so ArcHydro is available on both. What we'll do is usually a couple of weeks after the big releases of our core software, we'll have an ArcHydro release that matches that version of software. But in between, the updates to ArcHydro are tied to either new development that we work on with our clients, like Sandra and St. John's. So while we were developing the Hydroperiod tools, we might have had an update every couple of days to make those tools immediately available both to her team and anybody else who's interested in. Or if there are any fixes or bugs or improvements in performance, we'll release it pretty much anytime we feel like it. Very technical. And the way you access all that will be through the ArcHydro GeoNet page, and that will have the announcements for the major releases. And there's going to be always a discussion about any of the fixes.
Excellent. Thank you, Dan. The next question I have is actually to Sandra. As a user of the Hydroperiod tool, can you think of some other examples of users or projects that you're aware of that this tool has been used for?
Is my mic working? Am I on? Can you hear me?
You are.
All right. Well, we had a really interesting project with wetlands, soils, and oxidation using the Hydroperiod tool to demonstrate what level of inundation was required to prevent oxidation of soils. We had an area where the soil had declined, you know, there was a dropping, and trying to figure out what was happening, and it really had to do with the wetlands being inundated insufficiently during that time. So the Hydroperiod tool was very useful for that. And as Bakari mentioned, the water supply impact study, we used it to evaluate different scenarios of withdrawals from the St. Johns River and how that would impact the wetlands along the river. So those are two examples. We've used it on quite a few different lake and wetland systems for the MFL program as well.
Great. Thank you, Sandra. So Bakari, have you had a chance to play with the tool a fair amount as well?
Yes, I've used it for multiple projects. Yes.
That's
I
great.
just gotta, I'm gonna interrupt. We have Andrew is texting me. Andrew Sutherland, who is our MFL coordinator. And he said, what about lake lobe asynchrony? That was so cool. You've probably saw from the from the pictures that Lake Butler has a bunch of different lobes, and they don't all go up and down the water. The stage does not go in synchrony. Yes. And he also says tracking lobe behavior in sandhill systems. So yeah, it's been very, very valuable just to to understand system behavior using the Hydroperiod tool. Anything else, Andrew?
Thank you, Sandra, and thank you, Andrew, for puppeteering over there. That's helpful. So there's a great question coming in. Someone's asking if the hydro if ArcHydro could be used to determine if an isolated pond is subject to inundation from a nearby stream. So I think I might direct that over to Dan.
Yeah, so technically, yes. So from the point of view of GIS analysis and terrain analysis, you can. You just check whether the polygons or the rasters are directly connected to the stream. As a hydrologist in my previous life, unfortunately, water doesn't necessarily follow topography, but will want to seep. If you are in Florida and there's karst, there's all kinds of crazy ways in which water will get to an isolated area that's really not related to surficial and topography. So tool-wise, yes. Logically and physically, who knows?
Yeah, I can think, Dan, the Cloud Forest project that I've been helping with the last 10 years down in Guatemala, it's all super high elevation, very young karst, and you have rivers popping out of the mouth of a cave for 100 feet and then disappearing again. And yeah, that water is not paying attention whatsoever to the contours.
So it's a good starting point, but you have to bring everything in.
Yeah. Great. Well, thank you. So Daniel, there was a question that came in respect to the Living Atlas, and it kind of reflects something that you and I were talking about yesterday. Like when utilizing the Living Atlas, especially for people who are just exploring with it, it may seem difficult to access some of the data that we might be looking for as scientists sometimes. I'm wondering if you could address that a little bit, just from, again, based on our conversation yesterday when you and I were talking about comparing the soils and what was available in the Living Atlas versus, what's available on the Web Soil Survey.
Yeah, great question. So since we were discussing that, I went back and was looking around a little bit more and verified our suspicions. And whereas maybe the data is presented slightly different, like the pop-up that you get in ArcGIS Online may not have exactly the same data that you would expect accessing it through something like the NWI tool. The underlying data is all the same. So Living Atlas can be viewed as a way to access data. So it's a very easy way to go to one place and bring in fish and wildlife data, USGS data, a whole variety of different data sets without having to go to multiple different websites. The underlying data that you are accessing is the exact same data that you would be getting from the different agencies. So whatever data is being presented by the agencies, then that's what you would be accessing through Living Atlas.
Great. Yeah. Well, somebody just followed up there with another question. Does the Living Atlas have streaming USDA soils data? And I think that's kind of what we were just getting at there, but you want to open that one up a little bit more?
Sure. Yeah, I'm actually not 100% familiar with that particular data set, the streaming soils data. But I think that what we were just saying holds is that whatever data is available from the agencies, they work directly with the Living Atlas team to ensure that same data set is represented within Living Atlas.
Yeah, and what an incredible set of data to have available all in one place. I mean, that's typically as part of my workflow whenever doing a delineation or monitoring site, you know, that first initial creation of the base map, of gathering up all of the necessary data in order to pull together the specific data that I need to either conduct the delineation or the monitoring to have that resource available so much more efficiently is pretty exciting.
Yeah, that's why I just have to laugh at like my past self, who had, you know, spent a lot of time trying to gather, you know, different data sets for something just simple like a base map, which now using Living Atlas I could do in 5 minutes. And it's not just the wetland data. I can add roads, streams, land cover, all variety of different data sets that I would have spent hours hunting for in the past. I can bring them in and be assured that they're all up to date.
Yeah, it's exciting also to think about how potentially long-term some of the different projects that people are working on and out on the ground in terms of monitoring or data collection could potentially help to better inform those data sets, so that, you know, looking at macro scale modeling and planning can play a much more active role in that. That's some pretty exciting stuff for me to think about, and I imagine for a lot of people who are on this webinar with us. So why don't we pivot and switch gears, and I want to run a question over to Alan and to Jacqueline. You know, so it just came onto many of our radars, the whole APT tool becoming available. I was actually on a webinar, and somebody from the Army Corps of Engineers mentioned that back in, I believe it was July, right when it first came out. And so, you know, I know that it's a beta version that has been released out. And so, Alan, Jacqueline, were you guys invited to test that, or was that something that you just were given privy access to, and so then you've just been using it for the last few months? Either if one of you wants to chime in, that'd be great.
Sure, I'll take that one. You know, we were tipped off that it was available for use, and so we started to try and incorporate it and learn what sort of information it would help us, you know, make more robust in our delineations. We played around with it, figured out that it could potentially replace those WETS tables that I know everyone loves doing when they're doing delineation reports. So it kind of just saved us some time, and we were able to incorporate it into our reports, and it's useful for some of our clients who, I mean, if you think about it, when you incorporate the data that the Corps of Engineers is already going to be doing, you're removing one step of the process that they have to do themselves. And if you've already analyzed that data, it sort of hands it to them on a silver platter. So I think it makes it easier for everyone that, you know, your wetland scientist is out in the field completing the wetland delineation, is informed about what conditions they're observing their wetlands at, and then taking it back, writing a report about it, and providing that to the Corps of Engineers, who ultimately makes the decision. It just makes everyone happy and able to use better data. So.
Yeah, that's exciting. Anything you want to add to that, Alan, since you were probably using it and running the model there?
Nothing much to add to it. I was Jackie was spot on with what she said. I mean, it's been really cool. It's been really useful, and I really like that it provides that graphic that that our clients seem to enjoy that as well. So
Great, thank you. Yeah, so I've been starting to back and forth a little bit with Jason Dieter. So pie in the sky vision for me would be collaborating with the Corps and pulling that tool into Ecobot so that you could just go ahead and run a query while out in the field based on your location. That would be interesting. I hope my developers aren't listening to me and thinking, uh-oh, how are we going to do that? But it could be really, really interesting thing to collaborate on. So
it would be great to have it all in one place.
yeah, it would. It would. So, well, I certainly appreciate everyone's time today. It doesn't look like there's any other questions coming in. Great overview of the APT tool, great overview of the Hydroperiod tool. Certainly appreciate everyone taking your time to join us for the webinar today. Again, keep your ears to the ground or emails or social media to look out for our next webinar focused on policy and tech in mid to late November. So again, thank you everyone. And we'll look forward to seeing you again soon. And want to once again give a nice shout out to all of our presenters, Alan and Bakari. You guys did great. And Daniel, once again, thanks for co-hosting this with me. And Sandra, Jacqueline, and Dan, thank you for helping put this together as well and being valuable resources and soundboards. All right, well, thank you everyone. Take care.
Thank you again, Jeremy. This was a really great experience for us, and we're really happy to have been part of it. Thank you.
You betcha, Sandra.